One of the big things about astronomy is that you only ever have what you can see, and you've got to deal with it. I was drawn to astronomy from a young age. That the things you look at through a telescope, they really spark your imagination when you're little. There's definitely this idea that we've got to go bigger and better and deeper all the time. What I do is actually go back into all the huge amount of data that's being collected by people and pull out some new stuff, squeezing out the truth that someone else didn't spot. By getting lots of people to look at every image, crowdsource that problem, we get a better result than we would if we just did it on our own. People are also not astronomers, and this is of great benefit to us because the astronomers that would have been looking at these images, they have an expectation of what they should see, and they might be wrong. We can go much deeper, have a much more complete picture, but an unbiased one as well. When the original Galaxy Zoo project launched, and more than 100,000 people came along that year to help us, and since then we've launched about 30 new projects, all in different areas from astronomy to zoology. One of the most exciting things about the Serengeti project is understanding the big predators in Serengeti National Park. We've got more than 200 cameras stationed evenly around the park, so we can see the movements and the motions of the animals. The Milky Way project is about getting the public to help us map the galaxy. The idea was to look for these things called bubbles. Bubbles in the infrared are where a star or stars have formed. They give off radiation, and it literally pushes the material that's around them out of the way. We see it as a round ring, and so that's what we're getting people to look for. When we were at school, we all learned about the planets in our solar system, but there's all these other planets in the universe going around other stars, extrasolar planets. So we call these exoplanets for short. We've been looking for exoplanets for nearly 20 years now, and that's what Planet Hunters does. Looks at the changing curve of light coming out of the star and looks for dips and says to people, when you see a dip, draw a box. Planet Hunters has been excellent at discovering planets computers can't spot. There's a planet known colloquially as Tatooine because it's the first planet we found that orbits two suns. These are light curves that look crazy to a computer, but people might just see it and think, that's kind of weird. One of the cool things about being part of these kind of mass participation projects is that I get to convey the excitement that I feel as an astronomer when I discover something to the people who get to discover it for themselves as well. People will say, oh look, I found a bubble. And you can say, hey man, that's a planetary nebula. Or you can say, super exciting thing, no, that's stupid. Or actually, that is a pixel that broke on the telescope.
It's really unique to get that first look. I was just immediately hooked. You just got to say, well, okay, give me another picture of a random galaxy that's millions or billions of light years away and let me discover something new about it. You got to see absolutely stunning, beautiful images, and you're making an authentic contribution to science.
Looking ahead, one of the situations in which this kind of model won't quite work, and we need to figure this out, is disaster relief. Well, we have satellites that can take images of whole cities. Well, we could start to track where the problems, where the issues are. We just need to figure out how to deploy the data quickly enough, get the crowd motivated to look at the data, and extract the answer all very quickly. And that's really exciting and really important.